Hi everyone. So today we will be discussing the January 2022 M3 unused paper. Let's start with question number 1. They say a light elastic string AB has natural length 11A and modulus of elasticity 6 mg. A particle of mass 4m is attached to the point C on the string where AC equals 6A. Okay. And a particle of mass 2m is attached to the NB. Okay, shall we first draw this string in its natural length? So when you consider this string in its natural length, so this is AB. The total natural length is 11A and the lambda value is 6 mg. So they say the particle of mass 4m is attached to point C where AC is 8A. And you see AC is 8A and you attach the particle of mass 4m. And then what do? Again, they say, and a particle of mass 2m is attached to NB. So at the NB, you have a mass 2m. And then what do? The end of the string is attached to a fixed point and the string hangs vertically below. Okay, so obviously you know it's elastic string. When you hang this, will it be in these lengths 8A and 3A right here? Will it be responding with these lengths? No, with the weight of the particles, the strings will extend. So what you do here is at the point where each particle, at the point where you have especially the particle in the middle, you can consider this as two separate strings and do the sum. Okay, let's see what I'm talking about. They say the end of the string is attached to a fixed point and the string hangs vertically below A with the particle of mass 4m in equilibrium at the point P and the particle of mass 2m in equilibrium at the point Q as shown in figure 1. Find the length of AP. Okay, so here they have drawn the extended version. Do you see? So in this extended version, because of the weight, this is moving down. So as I told you earlier, okay, what you should do here is that because you attach the point P to the to somewhere, to this string in the mid, not exactly in the middle, but because of this point P, we will be considering AP as a separate string and PQ as a separate string. Okay, so let's apply the forces. So how do we do this? Okay, so they're asking us to find the length of AP. How do we find the tension in the string AP? So first of all, let's mark all the forces. What are the forces we have here? Let me make this large. What are the forces we have? First, you have the tension, right? The tension in the string AP. Are you with me? So tension in the string AP. I'll say it as tension A. And then what about the other side? So on the other side, you have the other string, right? So if this is the other string, then the tensions are going to be different. So this is tension B, equal opposite tension B over here. Are you with me? What are the other forces you have to mark here? The weight. So here you have the 4 mg weight. And here you have the 2 mg weight. Are you with me? So these are the forces that you need to mark. Okay, is that clear? Okay, now the first thing is to find the length of AP, we will consider the AP string and apply tension equal lambda x over L. So first of all, is there any way to get the tension A value? So let's consider the vertical equilibrium. When you consider vertical equilibrium, of the full system, what do you have? The upward forces balances out to the downward. So tension A is upwards, and then you can see tension B up and down forces, right? Can you see it cancels off with each other, up and down. So then tension A is equal to 4 mg plus 2 mg. Do you agree? Tension A is equal to 4 mg plus 2 mg. Thereby tension A is equal to 6 mg. Okay, so now we can apply tension is lambda x over L. So tension A is 6 mg. Lambda value is how much? How much is the lambda value? Modulus of elasticity is 6 mg. Extension is what we are trying to find. Now remember, we are applying this for the AP string, okay? So extension is the value that I'm trying to find. Over natural length, what's the natural length of this AP piece of string? What was the natural length of the AP piece of string? AP was, before it became AP, it was AC, right? The point C became, is extended to P here. So AC is the natural length, which is 8A. Are you with me? Okay, so now it's a matter of making X the subject. So you can, I think 6 mg completely cancels out and you get X equals, this is 1 here. 8a. X equals 8a. Are you with me? So if the natural length here of the AC of this string was 8a, and if it is extended another 8a, what's the AP length? The natural length plus the extension. Natural length was 8a. Extension is also 8a, which means AP is 16a. Do you agree? AP is 16a. Shall we find the length of PQ? How do we find the length of PQ? So again, when you go to find the PQ length, you will be considering the PQ part. So PQ part, you can see PQ was originally the CB piece of string. So the original length is the CB one. So first of all, shall we find tension B? Because tension B is what we'll be using to get the extension. So how do we get tension B? How much is tension B equal to? So in here, you will consider the equilibrium of only the particle Q. Now, previously to get tension, I considered the vertical equilibrium of the entire system. But now we will consider vertical equilibrium of whom? I will consider the vertical equilibrium of Q, only Q. So if you consider only Q, this is the Q system. Can you see? Like in mechanics 1, you consider only that particle and the forces acting on that particle should be in balance. So what do you see here? Tension B is equal to 2 mg. Okay, so then we'll apply tension B is lambda x over L. Lambda tension B is 2 mg. Lambda is modulus of velocity. Does it change just because I have the same string in two different parts? No, lambda is the same. Extension is unknown. Let's say it's now y because we used x earlier. In the same sum, don't use the same variable twice. Natural length of this PQ piece of string is how much? The natural length of this PQ piece of string is 3a. So mg will cancel out and you get y equals 2 times 3a over 6, which gives us how much? Y is 4a. Sorry, not 4a. Y is 2 times 3, 6 and 6 cancels. Y equals 8. Then what's the length of PQ? The length of PQ string is the original length plus the extension. Original length of PQ was what? The original length of PQ was the CB length, 3A. Extension is A. 3A plus A, how much is the full length of PQ? PQ is 4A. Okay, this is clear. So this is the answer for, so this is the answer for, question number 1. Okay, so we'll go to question number 2. They say a particle P of mass n is attached to one end of a light inextensible string of length A. It's an inextensible string. Okay, so there is no extension. This string length is staying exactly the same. The other end of the string is attached to a point A, which lies above a smooth horizontal table. Okay, the particle P moves in a horizontal circle on the table with the string taut. Okay, so it moves on the table. On a horizontal circle on the surface of the table. The center of the circle is the point O, where AO is vertical and the string makes a constant angle theta degree with AO. Okay, as shown in figure 2. Given that P moves with constant angular velocity 2g over A, root 2g over A, find the range of possible values of theta. Okay, so basically this is what motion are we talking about? What lesson is this? This is circular motion. In circular motion also you have two types of motions we discussed, horizontal circular motion and vertical circular motion. Are we discussing about horizontal circular motion or vertical circular motion here? This is moving on a horizontal table, right? It's moving on in a horizontal circle. The word itself is given. It's moving on a horizontal circle. Okay. So in a horizontal circular motion, there are two things to do. Only two things. What is it? In a horizontal circular motion, your forces are in vertical equilibrium, and the other thing you do is you apply F equal ma towards the center of the circle. Okay. Can you tell me what are the forces acting on this object? What are the forces acting on this object? Normal reaction. You have the normal reaction. And also, did you see there's a string attached to this? So definitely there's tension. And you have the weight. So mass is M, which means weight is mg. Can you see these are the forces, and the angle theta we can bring it as alternate angles over here, right? Can you see? Okay, so these are the forces: tension, normal reaction, and the weight. Okay. So now what we do is we will apply vertical equilibrium and F equal ma towards the center. What are the forces we consider for vertical equilibrium? Upwards. So you'll have to resolve the tension, right? What do you get? Upwards. When you consider vertical equilibrium, R plus T cos theta, right? R plus T cos theta is equal to mg. Do you agree with me? And then when you consider F equal ma towards the center of the circle, towards the center, what are the forces that acts towards the center of the circle? Yeah, T sine theta. T sine theta. Is that all? Do we get any components with normal reaction and weight? No, they are vertical. So they don't affect the horizontal. Okay, so this is the forces towards the center. So T sine theta equals to what? M acceleration is equal to R omega square, right? We can use R omega square or V square over R. Which one is more appropriate? We will use R omega square because the omega is given. Angular speed is given. What is the radius of this circular motion? What is the radius of your horizontal circle? The radius is, you can resolve this length of the string, right? The length of the string is A, so it's A sine theta. Do you agree? MR omega square. Let's input the value. T sine theta equals M. Radius is A sine theta. Omega square is, so they have given you the omega value here. Omega square is directly 2G over A. Do you agree with me? So we can simplify. A to A will cancel out. And do you see that there's more things that cancels out here? 2mg sine. Do you see sine theta is there on both sides? Sine theta will cancel out. So you get tension equals 2mg. Tension equals 2mg. Okay, so now input the tension value into the first equation. R plus T cos theta equals mg. Replace R plus T is 2mg equals to mg. So I get here R equals mg. I'll make R the subject because the thing is they are asking you to find the range of possible values of theta, right? They're asking you to find the range of possible values of theta. So range of possible values of theta in the sense, now if you go to make cos theta the subject here, you run into a problem because we do not know the value of R. So now to get the range means that it's like there's an inequality, right? So how do you create an inequality in this question? How do you create an inequality? This is something we've done before. So in this horizontal circular motion, this circular motion is there as long as what? The normal reaction is. What do you have to say about the normal reaction? It needs to touch the ground, right? So it should be greater than 0. Actually, they even give correct if you say R greater than or equal 0 is also okay. Okay, so you could say R greater than or equal 0. Both of them are acceptable. So R greater than 0. Let's input the R value. R value is mg minus 2mg cos theta is greater than 0. Are you with me? So the negative 2mg cos theta, I'll take the other side as positive. That will not change the inequality sign. Just 2mg cos theta. Now we will divide both sides by mg. M and g are both positive constants. Thereby, we will not damage the inequality sign. Are you with me? Because you are actually, when you're cutting, you're dividing. When you're dividing with an inequality sign, you need to be really cautious because if you divide with a negative number, the inequality sign will change. So here we are dividing both sides by mg. That's why it cancels. But m and g are both positive. So here the 2 comes to the side as division, which is half. So cos theta should be less than half. So now you have to find the range of possible theta values where cos theta is less than half. How do we find the range of possible theta values where cos theta is less than half? Yeah, we will give an angle here. The angles, they say here, angle theta degrees. So how do we get the theta value? Now, just by inspection, you know, this theta, can it be obtuse or reflex when you're trying to touch the ground? Your theta must be definitely acute angle, isn't it? This theta is definitely acute. Okay, how do I get the range of theta values here that satisfies cos theta less than half? So one way of looking at this is I quickly, remember the cost graph. I just quickly remember the cost graph. You remember how the cost graph goes, right? Cost 0 is 1. Do you agree? Cost 90 is 0, right? Are you with me? Cost minus 90 is 0. So that's how the graph goes. Do I need to extend this? Now you know your theta is acute, isn't it? Do I need to extend this any further? Do I need the negative theta values? No, right? So your graph comes like this, but I'm only concerned with this part. Like I don't need the other part. This part is not necessary. Are you with me? So this is the part of the graph that I'm concerned with. Okay, so now what? In this graph, we need the cost, the theta values where what? Where are the cos theta functions? This is the cos theta, right? Where the cos theta values are less than half. So, half is somewhere over here, right? This is 1. This is the half. So where do you get the theta values less than half? First of all, at half, can you get the theta value? Who is the cos theta value at half? Cos inverse half, which is 60. So which part of this graph will give you cos theta values that give you an answer less than half? Less than half means you have to get the values below half. So which part of the curve? Is it the top part or the bottom part? From where? It's this range, right? You see every theta value in this range gives you cos theta values less than half. Can you see? So what's your theta value range? More than 60 and less than 90. This is your theta value range. Okay, is this clear? So it's easy to understand that by thinking of the graphs. Okay, so now I move to question number 3. They say here a particle P is moving along the x-axis. At time t seconds where t is greater than or equal to 0, P is x meters from the origin and is moving with speed v. The acceleration of v has magnitude 2 over 2x plus 1 to the power 3 meter per second square and is directed towards O. So really important you identify that it's coming towards. Okay, so if it's directed towards the origin, you need to realize the acceleration you have to use it as a negative figure, right? So you have to take the negative of this value here. When time 0, P passes through origin. Okay, so time 0, at time 0, in other words, x is 0. With speed, velocity 1. Okay, v value is 1. Find v in terms of x. How do we find v in terms of x? First thing is write the a value. A is 2 over 2x plus 1 to the power 3, power minus 3. Is that all? Sorry, power plus 3. What extra thing do you need to add here? They say the acceleration is directed towards O. Therefore, make sure you put a negative sign. And then how do we deal here? Acceleration is a function of displacement here, right? So we have two types of acceleration as a function of time and acceleration as a function of displacement. Acceleration as a function of time, we write dv by dt. Acceleration as a function of displacement, we write v dv by dx. Are you with me? So here I will write acceleration as v dv by dx equals minus 2 over 2x plus 1 to the power 3. So to get the velocity, I'll have to integrate. So when you're integrating, you have to separate the variables, x terms on the side with dx and v terms on the side with dv. So then I'll take dx to the other side. I get here v times dv minus 2 over 2x plus 1 to the power 3 dx. Are you with me? So now we can integrate both sides. This side integrates with respect to v, the other side integrates with respect to x, but over here you have power 3 in the denominator. So before integrating, what should I do? I'll take the minus 2 out and I get here 2x plus 1 to the power minus 3. Is that okay? Now we'll integrate. When you integrate v with respect to v, we get v square over 2. Here minus 2 times 2x plus 1 to the power minus 3. When you integrate 2x plus 1 to the power minus 3 plus 1 is minus 2 divided by minus 2. In addition to that, now this minus 2 was outside. This came with the power. In addition, you have to also divide by the coefficient, right? Coefficient of x, there's 2x here, which means there should be another half. And don't forget the plus c. Okay, so let's simplify here. We get v square over 2 equals 2 cancels off here. Minus divided by minus is a plus. 2x plus 1 to the power minus 2. And because of this half, you have a 2 in the denominator. Are you with me? They're asking you to find v in terms of x, isn't it? So before you go to make v the subject, first you can keep it in this manner. First get the c value. Okay, so you don't necessarily have to make v the subject and then put the v and x values to make to get c. Okay, so you can leave it at this stage. So what are the values you can input to find c? They have told at time 0, we don't have time here, but we have it passes through the through O, which means x is 0 in the positive x direction with speed 1. So speed 1, which means v is 1. So you can replace here when v equals 1, x is 0. So substitute, we get here 1 square over 2. This is 2 times 0 is 0 plus 1 to the power minus 2 divided by 2 plus c. So what do I get here? 1 over 2. 1 to the power minus 2 is 1 over 2 plus c. What do we get here? You know this half is going to the other side. Is the 2 going as a multiplication? No, right? It's the entire half. It should go to the other side as a minus half. So half minus half equals c, which gives me 0. C is 0. Is that okay? So now we'll come back and use it into our equation. So main equation now becomes b square over 2 equal 2x plus 1 to the power minus 2 divided by 2. C is now 0. Now our task is to make v the subject. So you can see the divide by 2 also will cancel out. This part is not 0. So v square equal, shall I write 1 over 2x plus 1 square? 1 over 2x plus 1 to the power 2. So basically when you make v the subject, okay, so when you make v the subject, what do we get? V equals square root. So v equals 1 over 2x plus 1, and this is your final answer. Is this okay? Yeah, so this is 1 over 2x plus 1 square. So that's why when you root it, square root of 1 is 1. 2x plus 1 square is directly 2x plus 1. Then the next part, they tell you show that x equals half root 40 plus 1 minus half. Okay, how do we get the show that for x? So how do we get the show that for x? What did you do? Okay, so we need x in terms of t. We already found v in terms of x, right? V equals 1 over 2x plus 1. So we know for velocity, we have the fixed equation. Velocity is dx by dt. Are you with me? So dx by dt is 1 over 2x plus 1. Now again separate variables, the x term in the x side. So 2x plus 1 comes over here, 2x plus 1 with respect to x. On the other side, I have just dt. So when you integrate, this side integrates with respect to x. The other side integrates with respect to t. So 2x plus 1, when you integrate it, it's x square. So 2x square divided by 2, the 2 cancels. Do you agree? So 2x square divided by 2 plus integration of 1 with respect to x is x. Agreed? Then here, on this side, when you integrate 1 with respect to t, I get t, and don't forget the plus c. So once again, you have to find the c. So they have told you at time 0, x is 0, which once again tells you what? C is 0. When time 0, x is 0. So when all of these are 0, you get c equals to 0, right? Can you see? So I will directly write the equation x square plus x equals c. Now, you have to get the show that. In the show that, what have they done? They have made x the subject. In the show that, they have made x a subject. So let's make x a subject. How do we make x a subject here? So you can see you have a quadratic equation in x, right? If you want to make x a subject in the quadratic equation, what's the only technique that we have to do? We have to complete the square. So complete the square here. Instead of x, we write x square, we write x plus this 1x. So write half the coefficient. X plus half to the power 2 minus the square of half is 1 over 4. So this is the completing square. Okay, something you learn in P1 is equal to t. So now our task is to make x the subject. So x plus half to the power 2 minus 1 over 4 goes to the side as plus 1 over 4. So I'll make, I think the question has 40. So I'll make either common denominator here. So I get here 40 plus 1 over 4. Do you agree? When I take common denominator. Okay, then the next step, x plus half square. So I'm removing the square by taking the root on the other side. Are you with me? Okay, so you get plus or minus. Actually here, okay. So x equals, the plus half goes to the other side as minus half, plus or minus root 40 plus 1 over 4. So actually we will only be considering the positive part of the root here. Okay, because you can see that we have some displacements positive at the beginning. If you use negative here, you will see that all the displacements you get for on the all time values are negative. But they do tell you that at the beginning, the particle is moving in the positive x direction, right? With speed 1 meter per second, it's going to the positive x direction, which means you have positive displacement, right? So, you use with, you have to go ahead with this equation. That's the show. Actually, we have a show that here. Yeah, so to get the show that, what should we do? So x equals minus half plus, separate the root 40 plus 1 over root 4. Root 4 is 2, right? Because you can separate the third up and down. And then they have taken the half out. Am I correct? So you get minus 1 plus root 40 plus 1. Is this to show that? Yeah, half root 40 plus 1 minus 1. Same thing, right? Half root 40 plus 1. So this is the show that. Okay, is it clear? Just one more line of working here. Actually, it's better that you write here x is greater than 0. Thereby, you go ahead with this. Okay. As I was explaining to you that at the beginning of the sum, you saw that the particle was moving to the positive x direction, right? So if you use the minus half minus root 40 plus 1, you only get negative displacement, right? Do you see? So you have to mention x is positive. Therefore, you choose the positive figure here. Okay, so some kind of justification should be given why you choose as to why you choose this value. Okay, only the positive part. Okay, moving to question number 4. They say a solid hemisphere H has radius R and center O. Show that the center of mass of H is 3R over 8 from O, and you may assume that the volume of H is 2 pi R cube over 3. So this is a proof, a required proof that you are supposed to study in the M3 book. Okay, so you learn about this, you're supposed to know it. So there are certain proofs that you need to know, like for the center of mass of a hemisphere, solid hemisphere, center of mass of the hollow hemisphere, cone. So there are certain things that you need to know. So this is also one of them. So what's the main equation that we use to get the center of mass? So basically what we do here is it's a solid of revolution theory that we use. So what do we revolve to create a hemisphere? What is the original function? What original function is revolved around the x-axis to create a hemisphere? Your original function is a quarter of a circle. Your original function is a quarter of a circle, which forms the equation with center 0, 0, radius r. So we say x minus 0 square or x square plus y minus 0 square y square equals r square. This is the original equation. This, when you rotate 360 degree around the x-axis, you create the solid hemisphere. Are you with me? So this is how you create the solid hemisphere. Okay, so what's the equation to get the x bar? So there is a special equation. Y bar, there is no y bar because because it's symmetric around the x-axis. So what's the equation to get the x bar? X bar equals, we normally put just y square x, the integration of y square x dx divided by y square. But in this case, there is a pi in the original equation, pi y square x dx over pi y square dx. Now actually this pi will cancel out. Okay, that's why we don't need to use it. But you know, in the denominator, pi y square dx is what? The denominator pi y square dx gives you what? If you remember P4, pi y square dx is the volume of a solid of revolution, isn't it? The volume of a solid of revolution is pi y square dx. So the volume of the thing is given to you. The volume of the hemisphere is given to you. So do we need to find it by integration? So it's not necessary. So this is 2 pi r cube over 3. So basically the denominator answer is there. All you have to do is to get the numerator answer. So numerator should be integrated. So shall we input the value? So we have to get the integration of y square x. We will leave the pi outside for now. Let's integrate y square x. Who is y square? From the main equation, y square is r square minus x square. Do you agree? R square minus x square with x multiplied by x dx. So when you open the bracket, this is r square x minus x cube. Are you with me? So what happens when you integrate? And what are the integration limits, by the way? The integration limits for x are going to be starting from x0. It goes until x equals r, right? So your limits are from 0 to r. Are you with me? So r square, when you integrate x, you get x square over 2. R square is a constant. Minus x cube integration is x to the power 4 over 4. Your limits are from 0 to r. Are you with me? So this becomes, first input the value of x as r, you get r to the power 4 over 2 minus r to the power 4 over 4. Minus next one, you replace the x with 0. What happens when you replace x with 0? Everything becomes a 0. Can I know how much is r to the power 4 over 2 minus r to the power 4 over 4? R to the power 4 is common. It's half minus 1 over 4. How much is half minus 1 over 4? 1 over 4 r to the power 4. Is that correct? Okay, substitute to the main equation now. So substitute this answer into the x bar equation. So x bar equals 1 over 4 r to the power 4, which you divide by the pi y square is the volume, which is 2 pi r cube over 3. Are you with me? So we'll divide, and you know this is equal to 1 over 4 r to the power 4. The 3 comes to the top. 2 pi r cube stays down. So you can cancel out r cube with r to the power 4. 1 r remains on top. So you are getting here. Sorry, there's a pi on top as well, right? This pi. Yeah, so I only integrated the y square x part. So that answer is 1 over 4 r to the power 4 with the pi. There's a pi here as well. The pi will also cancel out. Is that correct? So then I end up getting here 3 into 1 is 3, 4 times 2 is 8. 3 into 1, yeah, and then there's a r on the top. So then you get your x bar answer 3r over 8, which is what is required, right? So show that the center of mass of the hemisphere is 3r over 8 from 4. Is it clear? Okay, move to part B now. Okay, so we'll move to the next part. They say a uniform solid S shown below in figure 3 is formed by attaching a uniform solid right circular cylinder of height h and radius r to capital H. Capital H was the solid hemisphere, right? So the hemisphere, you've attached a solid uniform right circular cylinder of height simple h and radius simple r. So to capital H is the hemisphere. So that one end of the cylinder coincides with the plane face of H. The cylinder and the hemisphere, they have the faces coinciding. The point A is on H. The point A is on H such that OA is R and OA is perpendicular to the plane face of H, which means they're saying A is the lowest point, right? Show that the distance of the center of mass of S from A is this. Okay. How do we get the distance of the center of mass? What I'll do is I'll quickly draw a sketch here. Object, this is part B, right? So the object, the mass from the center of mass. Okay, so what's the first object that we need to consider here? The hemisphere. So I'll first consider the hemisphere. So first object to consider here is the hemisphere. So we know the center of mass of a hemisphere. We found in part A. It's at a distance of 3r/8 along its axis of symmetry, right? Along the axis of symmetry, which means along this line. It's at a distance 3r/8 from the center. Okay, it's at a distance 3r/8 from its center. So now in this case, the thing is, I want to I'm interested in measuring all measurements from A. Okay, I'm going to take A as a 0 point and I'm going to measure everything from A, because to get this show that they have taken the center of mass from A. Okay, first thing is the mass. Okay, what do we say here? Mass is proportional to the volume. So what is the mass? Mass of the hemisphere is 2 pi r cube over 3, right? Is that okay? 2 pi r cube over 3. And if you want, you can multiply it with a constant because saying the mass per unit volume, right? Mass per unit volume is m. You can assume something like that and multiply. It will anyway cancel out. Okay, or else you can, yeah. And then the next one, center of mass. How much is the center of mass? 3r/8 from O. If it's 3r/8 from O, I want the distance from A. What's the distance from A? 3r/8 from O. How much is the distance to the center of mass from A? Yeah, OA is radius r, right? So r minus 3r/8. How much is the distance? 5r/8. Do you get that? 5r/8. So this is the first object. Second object, you're adding the cylinder. You're adding the cylinder. So it's a cylinder, radius r, height h. However, do you need to keep in mind that you are measuring from A? A is it at the bottom of the cylinder? No. A is somewhere over here, right? Because there is the hemisphere at the bottom, right? So you are measuring your distances from A. So bear that in mind. Okay, what's the mass of the cylinder? Mass of a cylinder. Volume of a cylinder is pi r square into h. So radius is r, height is h, pi r square h, and mass per unit volume, it's m. Okay, so we can leave it. If you want, it will anyway cancel out. Okay, so we normally use in the M3 book, sometimes they use it as rho. Okay. What's the center of mass? What's the center of mass? Distance from A. How much is the center of mass? Normally, you know the center of mass is in the middle. Okay, so as I was saying, the mass is pi r square h into mass per unit volume is m. Okay, or we can use rho. And then what about the center of mass? Now you know the center of mass, the cylinder has a height of h. The center of mass is normally located there in the middle of the cylinder. Am I correct? Your center of mass is supposed to be exactly in the middle of the cylinder. So which means how much? The height will be, can I know the height here? Talk with me. How much is it? Half h. It's half h. Are you with me? So this is half h. Okay. Then what's the distance of to the center of mass from point A? What's the distance to the center of mass to this point? You measure the distance. I want it from point A. Half h plus what's this distance? This distance is the radius of the hemisphere, isn't it? See, this O to A distance is the radius. So this is r. So center of mass distance is half h plus r. Are you with me? Final figure is the last one. So in the last one, what happens? We combine, right, the two objects together. We combine the two objects together. Are you with me? So this is point A. What's the total mass? So obviously total mass is when you add both of them, right? So shall we add both of them? What do you get here? 2/3 pi r cube m plus pi r square hm. Are you with me? Center of mass is the distance that we are trying to find. So I'll say it's y bar. Is that okay? Okay, so now it's time to get the show that. What do we do here? So this object, the hemisphere, you add the cylinder, you form the compound object, right? So let's multiply mass into center of mass. So what's the mass here? 2 pi r cube m over 3 multiplied by 5r over 8 plus, right? Pi r square hm multiplied by half h plus r equals, when you're taking this, shall I take the common thing out? Okay, in here, if you take the pi and m out, it's easy for us. 2/3 r cube, 2/3 r cube, pi and m comes out, you have r square h, right? So pi and m, I'm taking it out. I get here 2/3 r cube plus r square h, the total mass into y bar. Are you with me? Okay, so we need to get this show that. We have to rearrange this equation to get the show that. Okay, what can I remove? So you can see pi and m is common to all the three terms. Can you see? I told you m will cancel out. In here, m will cancel out. Right, then what else can we remove? I think we could take r square out from here as well, right? Shall we rearrange? This becomes 2 times 5, 10 over. Sorry, we can simplify. Can you multiply 2/3 into 5/8? What's the simplest answer? 2/3 into 5/8. This gives me 5/12. Is that correct? 5/12 r to the power 4. This part I get r square h times half h plus r. Is that okay? This side I'll take r square out. So I get 2/3 r plus h into y bar. Are you with me? So what do we get here? 5. I can remove r square. So from the entire equation, I will divide everyone by a r square. Are you with me? The whole equation r square is common. So we'll divide everyone with r square. What's remaining? 5/12 r to the power 4 divided by r square. So it's r square plus h times half h plus r equals 2/3 r plus h into y bar. So now it's a matter of simplifying and we need to get the show that. So this one, I'll open the brackets, 5/12 r square. This one, h into half h is half h square plus hr equals in here. Shall I take the common denominator? 2r plus 3h over 3. Is that okay? 2r plus 3h over 3. This is into y bar. Okay, so then to simplify, so you can see the denominator, I have 12, I have 2, I have 3. So to remove these denominators, what is the best number to multiply with? Common denominator of 12, 2 and 3 is 12, right? Let's multiply the whole equation, everyone with 12. So when I multiply everyone with 12, 5/12 r square into 12 gives me 5 r square. 1/2 h square into 12 will give me 6 h square. This is 12 hr. This is 12 hr. Here 3 and 12 cancels and you have 3 times 4. So 4 times 2r plus 3h into y bar. I think I'm getting to show that, am I? Yeah. 5r square, 12rh plus 6h square. Yeah, this is the h square, right? Yeah. And this one 8r plus 12h. Can you see? 5r square, rearranging as in the sum, 12rh, hr and rh are the same, plus 6h square divided by, this is a multiplication, comes as a division. This becomes 8r plus 12h equals y bar. Is that clear? So this is the show that. Okay, this is the show that. Okay, so now we come to the last part. So 5 mark part is done. So we'll move to the last part now. So in the last part, they say the solid S. So now look at this. It's just 2 marks. It's simply 2 marks. Okay. The solid disk can rest in equilibrium on a horizontal plane with any point on the curved surface of the hemisphere in contact with the plane. Find R in terms of H. What do you mean? What do you mean that when any point of the curved surface is touching the plane, what does it mean that it's resting in equilibrium? Now, normally, when you keep an curve, like say you have this just the hemisphere. So this is the surface. This is the ground. So this is the ground. So if you keep a curved surface and try to keep your, now normally a hemisphere would stay like this, right? But and if you try to keep it in this slanted way, does it stay like that? Does it stay like that? No, right? Sorry about the diagram. It will try to tilt back, right? It will try to tilt back, coming back to the original shape. Now in our shape, what's happening in our shape? In our shape, we have a hemisphere and a cylindrical part on top, right? There's a hemisphere and there's a cylindrical part on top. Are you with me? Okay. There's a cylindrical part. So now they say with this cylindrical part attached, what's happening? What's happening? If you keep it like this, is it going to topple over? They say when you keep it like the solid disk can rest in equilibrium. It can rest in equilibrium on a horizontal plane with any point of the curved surface of the hemisphere in contact with the plane. So if you keep it like this, it will stay here. It will stay here. Or if you keep it to the other way, even if you keep it to the other way, right? Even if you keep it to the other way, it will still stay, whatever the position you keep it. Are you getting the figure? What's going on here? So it's going to stay. It's not going to topple over. It's going to stay exactly where it is. So how is this possible? How is this possible? So let's talk about this object and talk about all the forces. Okay, what are the forces that are acting on the object? First of all, what are the forces we have? We have at the point of contact, we have the normal reaction. Okay, we have the normal reaction. And then at the point of contact, we have normal reaction and we have the weight. Weight acts from wherever your center of mass is. So if my center of mass is here, the weight will act from that point. And can you see normal reaction and weight are on one line? So is it so therefore these two forces are in balance, it's in equilibrium. Now normally in the other case, look at this case. Now in here, the object is touching at this point, right? The hemisphere. So when you draw the normal reaction, you are aware the normal reaction, it will pass through the center of the hemisphere, right? Are you with me? So what about the weight? Now look at this. Normally, I told you when you take a normal hemisphere and if you keep it, you expect it to topple over and come back to the original state, right? How does that work? How does that work? Now, you have your center of mass, right? So center of mass, let's think for a moment, the center of mass is at this point, the W is acting over here. What do you think will happen? Now R and W are equal, but but in here you can see when it's like this, it produces a resulting moment, right? Okay, R and W. So in here the W provides a resulting moment. In this case, it will topple this way. What happens if a W is on the other side? Like if it has passed R, like maybe let's say your center of mass is over here. What happens if a W is over here? This object will fall this way. Will fall because this has a higher weight concentration over here. So if you want your object not to fall over, where do you think the W should be? It should be, if you place this now on the axis, if your W is placed above here, over in this part, then the weight will cause it to topple over this way. If it's over in this side, it will topple this way. So where should W be if it's not going to topple over? Your W should be exactly, now your W has to be on this axis of symmetry of the object, right? Your W has to be exactly in the center of the hemisphere. In this case, do you see that if whatever the way I draw, now you can see here also normal reaction passes through the center of the hemisphere, right? So in this case, again, your axis of symmetry is like this. So you can see again, if you do it like this, if the axis of If the center of mass is on the at the center of the hemisphere, then again the weight acts like this. So regardless, whatever the way you turn, the R and W are always aligned. Can you see what I'm talking about? The normal reaction and W are aligned regardless of whichever point of the hemisphere is touching, the curved surface is touching, because whenever the curved surface touches the plane, you produce the normal reaction. The normal reaction will always pass through where? The normal reaction always passes through the center of the hemisphere. So if the weight of this compound object is on the center of the hemisphere, then R and W are always aligned. So if they are always aligned, what happens? If they are always aligned, will we produce a resulting moment? Do we have a moment? There's no moment here. So in that case, it will not, there's no turning force. Okay. So if the W and R are not aligned, it will produce a turning effect. Do you get what I'm saying? So then in this case, to find, at this point, what do you realize? From A to the center of mass. Now you got here the center of mass of S from A, right? So the center of mass value should be equal to what? The center of mass value should be equal to R. The distance from A, the center of mass distance, you measure it from this point A, right? So if the center of mass of the compound object is going to be at the center of the hemisphere, the center of mass distance must be equal to R. Is that clear? Okay, so basically you make this equal to R and then find R in terms of H. Okay, is this clear? Okay, so to give you a general idea about the rule that we use here, because you request a general idea, a general note. Okay, this is the theory. So whenever you have a curved surface, especially a hemisphere touching the surface of the ground, always remember the normal reaction will definitely pass through where? The normal reaction is definitely passing through the center of your hemisphere. Is that okay? That's rule number 1. Okay, that's rule number 1. So in all these questions, it's like that. The normal reaction should pass through the center. Okay. So let's say this is the point that we marked as A, right? I'm going to give you 3 theories here. Okay, that's why I drew 3 diagrams. And then this is the point O, right? AO. Okay, so wherever the center of mass is acting, that's the place I'm going to mark G. So I'm going to mark G in 3 places. First one, G inside. The next one, G is outside. And this one, G is going to be at the same place as O. Okay, so in here, in the first situation, you can see AG distance is less than AO. In this distance, AG is greater than AO. In this one, AG is equal to AO. Can you describe what's happening in each case? In the first case, what's happening? When AG is less than AO, what do you think happens when the weight is when the weight is acting over here? The particle will what? Always. So this will produce a resulting moment. It will come over here. It will topple and it will come back to the original position, isn't it? So if AG is less than AO, it will topple. It will come back to the original position. Okay. So this will come back to original position. What happens when AG is greater than AO? What happens when AG is greater than AO? It will completely topple over, right? It will completely fall flat to the ground. So it will fall like this, right? It will completely fall to the ground. Okay, I have it's difficult to draw it here. Okay, but the cylinder will lie like this at the end and the hemisphere, yeah. So it will completely topple over. Can you see? The object will completely topple over. And the last one, when AG and AO are equal, what's happening? This will be in, object will be in equilibrium. This is the case we are talking about. Object will be in equilibrium. Basically, at any point, yeah, it's touching the curved surface, it will just be in equilibrium. Do we have any Will we have any turning force? No. Okay, so this is the note that you wanted. Okay, so coming back to our question, all you have to do is make your 5r square plus 12rh plus 6h square over 8r plus 12h, make it equal to r. So let's make it equal to r. Simplify and make, they want you to find what? Find r in terms of h. Okay, get r in terms of h. Five r square plus 12rh plus 6h square equal 8r square plus 12rh, right? What happens now? When you look at this, now you're supposed to find again r in terms of h. R is subjected. So 12rh will cancel out. Bring the r terms to one side. So 6h square equal 8r square minus 5r square is 3r square. So r square is 6 divided by 3. 2h square. Is that correct? So r equals to root 2h square. So what does this give you? The root, the 2 will stay inside the root. Root 2 h square comes out of the root, right? Root 2h. H equals, r equals root 2 times h. Is this clear? Is this clear? So you don't, I just gave you a big explanation here. You don't need to draw any of these things. Okay. You don't have to draw any of these things for these 2 marks. All you have to do is figure out that your center of mass is equal to r and just do this part only. And you get the 2 marks. Okay. So I have given you the explanation of why that happens. Okay. Okay, question number 5. A particle P of mass m is attached to one end of a light inextensible string of length A. The other end of the string is attached to a fixed point O. The particle P is held at rest vertically below O with the string taut as shown in figure 4. The particle is then projected horizontally with speed u, where u is greater than root 2 ag. Okay, this should come up somewhere in the sum. We will see where it is, and then this should help us to figure out the u value. Okay, so for now you don't need to think much about it. Air resistance is modeled as being negligible. At the instant when the string makes an angle theta with the upward vertical, did you notice that? At the instant when the string makes an angle theta with the upward vertical through O, the speed of P is V and the string goes slack. The string goes slack. Show that 3V square equal U square minus 2AG. 7 marks. Okay. So normally when it comes to a question like this, what are the theories we need to work with? So for vertical circular motion, there are 2 theories. There is conservation of energy and F equal ma towards the center. Are you with me? Okay. So how does it work? Let's draw the diagram. So when you draw the diagram, you need to draw the circular path. They have told you that the circular path is going to be what? You make the angle theta to the upward vertical. Did you notice that? You make the angle theta with the upward vertical. Okay, so you have to mark theta and acute angle with the upward vertical. So when you come to this point, also you do realize for the string to become slack, it will not become slack in this, the first, over here, right? In the lower part here, the string will not become slack. The only way it will become slack is once you pass the first quadrant. This quadrant, when you pass this quadrant over here, this is a section where you can go slack. Are you with me? So let's mark all the forces. Let's say the velocity here is V. Okay, so what's the first thing we do? This I'm going to consider as my GP is 0 level. So we will use conservation of energy by the law of conservation of energy. Using conservation of energy. What's the energy we have? Energy at the beginning. Energy at P is equal to energy at V. So at the beginning, what energy do we have? We have kinetic energy. Right, so initial kinetic energy is equal to what? At the final stage, you have the final kinetic energy and the gravitational potential energy. So initial kinetic energy half mu square. That's the only energy you have in the beginning. You're in the GP 0 level. So there's no GPE. Final kinetic energy half mv square plus GPE is mgh. What's the height here? What is the vertical height over here? What's the vertical height? You do realize that this distance is the A, right? And then here this is A. So you need to resolve this A, right? This the length of the string is A here. So when you resolve, shall we bring the theta to the other side? By alternate angles, you realize this theta should come here. So then this distance should be what? This distance is A cos theta. Are you with me? A cos theta. Okay, so what's the total height then? The total height is A plus A cos theta. Are you with me? This is the total height. So into the value mgh is A plus A cos theta. So the whole equation has m in common, right? Shall I cut off the m? And shall I multiply everyone by 2? So when you multiply by 2, I get here u square equal v square plus 2g times A plus A cos theta. So I get here u square equal v square plus 2ga plus 2ga cos theta. Are you with me? This is the first equation. Now, to get this show that now you can see in the show that this is not the show that there's more to do here. So what's the next thing that we do? We have to apply F equal ma towards the center. So at this point, when the string goes like at the theta angle, we have to apply F equal ma. Can I know what are the forces acting at this point? Let me. What are the forces we have at this point? Yeah, we have the weight, right? So what's the weight? Weight of the object is the particle P of mass m, which means weight is mg. What else do we have? We have the tension. Okay, we have the tension. Okay, let me erase all these things. We have the tension. Okay, so you can see tension is directly pointed towards the center of the circle. However, mg, you will have to resolve and get the component towards the center. Are you with me? So what are the forces acting towards the center? Tension plus the mg cos theta. Are you with me? Tension plus mg cos theta is equal to ma. So let's apply F equal ma. Yeah, even vertical forces should be resolved towards the center. Because you have now see the only forces that we can't resolve is if it's perpendicular to this direction. Now the thing is, I want to apply F equal ma towards the center. So anyone who is not perpendicular, so mg is not perpendicular to this direction. So mg must definitely be resolved towards the center. Okay. Okay. So let's apply F equal ma towards the center. So I get here. So I get here towards the center. What are the forces we have? Tension plus mg cos theta equals ma. So m is mass is m, right? So just be careful here. If your mass is 2m, it has to be 2m. So here it's m, mass is m. Acceleration, normally centripetal acceleration, we have the equation v square over r or r omega square. So which one is more relevant in this case? We have the velocity at this point, right? So we will use v square over r. Radius r is a, right? Tension plus mg cos theta equals m, m over a, v square value we just found, right? Because v square is what we found on top here. Shall we input the v square value? V square equal u square. If you subject minus 2ga cos theta. Can you see? So I will replace here v square as u square minus 2ga cos theta. Are you with me? So I get here tension plus mg cos theta equals m u square over a minus 2 mga over a. Actually, you can see in this case, because it's m over a, the a will cancel out, right? So is it okay if I just remove the a? Minus 2 mga cos theta divided by a. Again, the a cancels. So just 2 mg cos theta. Can you see? So this is what I get at this point. I can't cut off the m here because m is not common to everyone. There's a tension here. Now, what's the special word they use here? They tell you at the instant when the string makes an angle theta with the upward vertical through O, the speed of P is V and the string goes slack. So when the string goes slack, what does it mean? Your tension becomes 0. So your tension is 0 as the string. When string is slack, so string is slack at theta. Okay, the tension is 0. So you write 0 plus mg cos theta equals mu square over a minus 2 mg cos theta. Is that okay? Okay, so when I come to this point now, I see there's a problem because in this show that there is a v square and I'm not having a v square here. Okay, can you see? So actually the problem here is I substitute the value of v square from the top part, right? So actually it's not necessary to substitute v square because v square is part of your answer. Or else if I come to this point, what I could do here is I could replace the cos theta by using the help of this and replacing cos theta again over here. Okay, so which is more work. So actually what I'll do here is I realize there is an error here. So I'll quickly remove this. Okay. So I'll quickly remove this part. And I'll come back from here. P plus mg cos theta. So have a look at your show that. Okay. Because the show that has the v square. So we don't need to substitute for it. P plus mg cos theta equals m v square over a. We'll keep the v square. Okay. So as the string goes slack, tension becomes 0. So you get 0 plus mg cos theta equals mv square over a. Are you with me? So now the m can cancel out and we can actually get a value for cos theta here. So for example, I get cos theta is v square over ag. Is that okay? I get cos theta is v square over ag. So now to get the show that what do? I take this cos theta value and I substitute for the first equation. Substitute the first equation. That's the easiest way to get it down. Substitute. Substitute to u square equal v square plus 2ga plus 2ga cos theta. So let's substitute u square equal v square plus 2ga plus 2ga cos theta is v square over ag. So I think you can see the ag will cancel out. So I get here u square equal v square plus 2ga plus 2v square. Am I correct? Okay, so there's 3v square inside everything. U square equal 3v square plus 2ga. So to show that is 3v square is u square minus 2ag, right? Yeah. So we get to show that 3v square equal u square minus 2ag. Ga and ag are the same thing, right? I took the term to the other side and it's a subtraction. Is that clear? So this is the show that for part A. Okay, so moving to the next part, they say from the instant when the string goes slack to the instant when OP is next horizontal. P moves like a projectile. So you do realize once when the string becomes slack. Okay, so you have to think about, what they are telling you about what's happening next. Now the string becomes slack at this point, right? So after it becomes slack, this particle P is acting like a projectile, which means it's an object moving freely under gravity, but it's going in the projectile path. Are you with me? The projectile path starts with what velocity? Starts with this velocity v. The projectile path starts with the velocity v, and they're telling you here the time from the instant when the string goes back to the instant when OP is next horizontal. What do you mean by next horizontal? So this is going to go in the projectile path. Okay, so you have your particle at this point now, right? This particle over here goes with this velocity. So at this point, the particle starts to go in a projectile. You see, it's going to move freely under gravity. So this is the origin. So they say OP is next horizontal means when this particle comes over here from the origin. Okay. So they're asking you, so the time taken is t. The time from when the string goes like and then the projectile goes like this and until OP is next horizontal because O is the center of the circle. The P is when it's aligning horizontally with the center. Okay. So they are saying this time taken is capital T. Given that theta is 30, the place where the string goes like this theta is 30. So that capital T is 2V over G. Okay. To get this, show that what we'll do is I'll draw this diagram on the main diagram. So basically what happens here is your particle now acts as a projectile. It goes like this, okay? I'm trying to draw something like this. Are you with me? Okay, so this is the place when it becomes horizontal again. Are you with me? Okay, so this is the place when it's next horizontal. So this time duration is capital T seconds. Okay. So initial speed is V. Look at this. Initial speed is V, which we marked over here. And then they have told you this theta value is how much? 30 degrees. This theta value is 30 degrees. Okay. So now we are going to apply the mechanics to M2 projectile motion equations are what we are going to apply here. Okay. What can we do here? I want to know the theta value. I mean, I want to use the equations for projectiles. So, can I know the angles here? Because I need to resolve the velocity, right? I need to resolve this V and get the horizontal component of velocity and the vertical component. So this theta value is, they have said that this is 30 degrees. Shall I mark theta as 30 or will keep it theta here and mark in terms of theta and theta will be 30. Okay, where else do we get the theta? So let me know where else do we get this theta? Now you do realize this is theta, which means this angle should be how much? This is the 90 degree here. This should be 90 minus theta. And then you realize that we have a 90 again here, right? This is perpendicular to the path, and this is I mean you can see these two. Radius and tangent are perpendicular, isn't it? So this is a 90 here. So if this is 90 minus theta, what do you think will happen to this angle? This should be theta again. Is that clear? So since this is a 90 over here, we need to realize that we are going to get this particular angle as theta. So we need that. Okay, so now I have the answer is coming in terms of V. You have to get the expression for capital T, the time taken to go in this path from until the object is horizontal. You have to get the expression for capital T in terms of V and G. Okay, so what equation are we going to use? Part B. What equations of mechanics 2 do we use? Yeah, so we know the time taken is capital T. We know the initial velocity, time taken is capital T. And we know the initial velocity of this path is V, right? The initial velocity is V. So what equation, what else do we know? So let's say this point is X and this point is Y. So I'm considering the path X to Y. We know the displacement. What displacement do we know? Vertical or horizontal? From X to Y, we know the vertical displacement. We know the vertical displacement. What's the vertical displacement from X to Y? What is the vertical displacement from X to Y? Look very carefully. This is A. Now you realize that this part doesn't count, right? So we need to get the shortest distance, shortest vertical distance from X to Y. Is it A? No, it's A cos theta, this length. It's A cos theta, right? This length is the vertical distance between X and Y. This, are you with me? This distance is the vertical displacement. This is A cos theta. Okay? So vertical displacement is A cos theta, and they have told you actual theta is what? 30 degrees. Are you with me? Is this clear? Okay, so then we'll use the equation what? S equals ut plus half at square, which way? I'll use it downwards from x to y. I'll use it downwards from x to y. So what's the displacement? We found the vertical displacement is a cos theta. What's the initial velocity? Initial velocity, initial vertical component of velocity. So initial now you don't put it as v. Initial velocity v means this is this is in this given path. You need to resolve. So what are your components? You get v cos theta and v sin theta. So this is v sin theta upward component. Are you with me? Okay, so we need the vertical component which is v sin theta. And time taken is capital T. Plus, and by the way, is this v sin theta is upwards, right? And I'm applying the equation downwards. Therefore, this should be negative. Okay, x to y displacement was downwards. That's why it's positive a cos theta. And then plus half into g is positive or negative? It's positive g because you're applying it downwards. G is positive downwards and capital T square. Shall we apply the values now? A cos 30 minus v sin 30 into capital D plus half gt square. You saw your answer comes in terms of t, capital T, v and g. So don't input the value of g right now. Let's solve the equation. A cos 30 is root 3 over 2. Am I correct? Minus v sin 30 is half. Plus half gt square. Shall I multiply the entire equation by 2? So I get here root 3a. Is a part of our answer? No. I get here minus vt plus capital GT square. Do you see what I'm getting here? I'm getting a quadratic equation in T. Can you see I get a quadratic equation in T? So 0 equals GT square minus VT minus root 3a. So we have to solve this equation. Okay, so we have to solve this equation. Shall we solve it? Solve this equation. So shall we go for the quadratic formula? T equal T square, because it's a quadratic equation in T, it's T equal minus B plus or minus square root B square minus 4AC divided by 2A. Okay, so what's our A value? A is the coefficient of T square, which is G. Who is our B value? Coefficient of T, which is minus V. Who is our C value? Minus root 3A. Let's input the value minus B. So minus B minus minus V. There's already a minus sign and B is minus V. Plus or minus square root. B square is minus V square. B square minus 4A is G. 4A C. C is minus root 3A. Divide by 2A. 2A is G. Are you with me? So T equals minus minus V is plus V plus or minus square root. V square plus 4 root 3 GA. Divide by 2G. You get something like this. Can you see? Are you with me? Okay, so now, how are we going to get the T value? We have to get our T value in terms of V and G, right? Okay, the first thing is, if you look at this, you can see this. We need to get the. We have to simplify this part. This part inside the root is the biggest issue here, right? So I think you can see for that. Just go through what we did before. Okay, because the thing is, we do not need this A value. Can I say we do not? The show that does not have an A. How do we get rid of the A? So if you look at what we did earlier, over here, can you see we got somewhere over here? Yeah, look at this guy. We got cos theta is v square over ag. Can you see? So we could use the help of that, right? Cos theta is v square over ag. In this case, cos theta is cos 30, right? Cos 30 was what? V square over ag, right? That's what we got. Do you agree with me? Okay. So cos 30 is how much? Root 3 over 2 equal v square over ag. Do you agree? So I get here a equals, if I bring a up, so ag times root 3 over 2 equal v square. Do you agree with my working? Which gives me, I'm trying to get a the subject. Okay, so a equals, because I don't need a. Okay, a equals 2v square over 2 3g. Or if you want, you could make both a and g the subject, because you can see both a g here. Can you see? Actually, we have all three. Root 3ga is there here. So you could like directly substitute root 3ga is the 2v square. Okay. So capital T equal v plus or minus square root v square plus 4 times root 3 times g times a is 2v square over root 3g. Are you with me? So root 3 cancels, g cancels. Is that okay? Divide by 2g. So capital T equals v plus or minus square root v square plus 4 times 2 is 8v square divided by 2g. So v square plus 8v square is 9v square. Root of 9v square gives you 3v. So I think you can see we get two answers. So your T is time. Time is a positive or negative figure. Time is definitely positive. Time is greater than 0. Therefore, we only need to consider the v plus 3v over 2g. Are you with me? So it is 4v over 2g, which ends up eventually giving us capital T equals 2v over g. Can you see the show that? Okay, so in the next part, they say, hence show that the string will start again when it is next horizontal. So next horizontal was over here, right? Now we marked it over here. You have to show that the string is start at this point. Again, the string becomes start. Start means what? It is fully stretched. If it is fully stretched, what's the distance of this line? This distance is A. If it is fully stretched, this distance is gonna be A. Now you have to show it. This distance is gonna be A. How do you show this distance is A? You have to show it becomes A. You have to get this distance and show it becomes A. So how do we show it? Right now, a moment ago, we applied S equal UT plus half AT square vertically to get the show that in part B, right? So for part C, what we do is we can use S equals UT horizontally. So when you apply horizontally, what happens? When you apply for part C, S equals UT only, right? You don't get the half AT square when you use horizontally. There's no horizontal acceleration. So you apply S equals UT. Now, the horizontal displacement, you need to show, now if it is fully stretching at this point, what should be your horizontal displacement? Like that's the value, what's the horizontal displacement you need to show? Now, you do realize if it is fully stretched, this distance should be A, right? And the thing is, what's the horizontal, when the projectile, when it's going, when the projectile goes from X to Y, what's your horizontal, what is your horizontal displacement? Is it only just this A? No, you also have this distance that you're traveling, right? When you travel from here to here, when you travel from here to here, your horizontal displacement is this. Can you see? I'm marking it in brown. Okay, so this is your horizontal displacement. Are you with me? So this distance is what you need to prove as A. You have to prove this. This guy, you have to prove it. Okay, so this distance, however, is fixed. Who is this distance? This distance. Who is this? This is fixed. Who is this? This is A sine theta. A sine theta. So this is, let's say this distance is x, because we have to show that x is equal to a. Okay. So then shall we input the value? S equals ut. So what's the u value? So u in initial horizontal velocity is? So we apply S equals ut horizontally. Okay. So listen to this. We apply S equals ut horizontally, and I need to show this displacement. If the string becomes taut, the displacement is, I will find the horizontal displacement and show that it's going to be, instead of using x here, maybe we could find the total value here. A sine theta is 30, right? A sine 30 plus A. So if you know, let's get the value. A sine 30 plus A is actually how much? A sine 30 is half plus A, which is half A plus A is 3A over 2. It's 3A over 2, right? Okay, so initial velocity. Now I found that this distance, the distance that you need to prove here is that it moves if the projectile moves a horizontal distance of 3A over 2, the string becomes taut. Again, when it at this point, when the string becomes horizontal, it will become taut. Okay. So we have to prove that our displacement is 3A over 2. So I'll apply S equals ut. So u is the initial horizontal component, which is v cos 30. Theta is 30 and time is capital T, right? And v cos 30 is root 3 over 2, right? And capital T, we just found what's capital T? 2v over g. 2v over g. Do you agree with me? So I get here 2 will cancel out. I get here root 3 v square over g. Root 3 v square over g. And didn't we get some kind of a show that for v square? Yeah. Can you see here the v square value? V square is, can you see from the earlier show that cos 30 is v square over ag? Let's use that again. So we found also what cos 30 is v square over ag. Are you with me? Which means v square is ag cos 30 times ag. Or ag cos 30. Shall we input the value? Substitute. So root 3 over g, v square is ag, cos 30 is again root 3 over 2. So g cancels, root 3 into root 3 becomes 3a over 2, which is our show that. So when it travels a distance 3a over 2, okay, so which you can say 3a over 2 is the a, I mean, it's half a plus a, right? So a sine 30, I mean, we just showed. You have to show this value also, right? For string to be, right, this also, for string to be taut, the horizontal distance should be equal to this. So we got the same answer, right? So we got the same answer, which means string is taut. So you can write string is taut. When OP is horizontal, and give your conclusion. Okay, is this clear? Okay, so we'll move to question number 6. They say a particle P of mass m is attached to one end of a light elastic spring of natural length 2L. The other end of the spring is attached to a fixed point A. Okay, the particle P hangs in equilibrium vertically below A. Okay, at the point E where AE equals 6L. The particle P is then raised a vertical distance 2L and released from rest. Okay, So first, let's draw a diagram. What's happening? So you have a particle B. This is first of all, it's hanging in. It's vertically, right? So you have a spring. It has natural length 12, and then the other end of the spring you are attaching it to a fixed point A. So this is the fixed point A. So you have your spring. So they say the particle P hangs in equilibrium vertically below A at the point E where AE is 6L. Okay, so the natural length was 2L. Okay, natural length was 2L. The natural length is 2L. And then I think you can see the remaining 4L is entirely the extension, right? The natural extension. So this is the point E. So this is point A. This is the point A. Do you agree with me? The point A is where it is hanging in equilibrium. At the point where AE is 6L. The particle P is then raised a vertical distance 2L and released from rest. So now this is in equilibrium at this point. So this E is the equilibrium point. So from point E, they are raising it a distance 2L above point E and they release it from rest. So they are saying show that P moves a simple harmonic motion of period T. So what do you know? I mean, what do you remember here? So whenever an object is in equilibrium at a certain point, when you have these springs and strings, especially in vertical springs, you can see when the object, if there's a certain place where the object is in equilibrium, that point is considered the center of the SHM, right? So so whatever the distance you move, so this is your center, the center of your SHM. So if you raise this distance too well above the center, what does it mean? What does it tell you about the distance too well? You are raising it a distance too well above the center, right? So if you are raising a distance too well above the center and you release it, what does it mean? It means the amplitude of your simple harmonic motion is going to be 2L because you are raising it a distance too well above the center. So that is the amount, the maximum displacement that you are taking above the center. So that will be your amplitude and you release from rest. So from that point onwards, you have SHM with amplitude 2L around the center. Okay. Okay, so how do we show that it moves with this SHM? Okay, so first what we will do is we will consider this equilibrium position and calculate the value of lambda before we go for the proof of the SHM. Okay, so before going for the proof, let's mark the forces at the equilibrium position. What do we have? So you have the tension and you have the weight, right? So weight is mg. So when at the equilibrium position, you know the tension is equal to mg. So your tension is equal to lambda x over L equals mg. Get the value of lambda because lambda is an unknown here. Do you see? Lambda extension x is the distance it has stretched beyond the natural length, which is 4L over L is the natural length, which is 2L equals mg. So L cancels out and 2 and 4 cancels out. 2 times 1, 2 times 2. So you get lambda equals half mg. Lambda equals half mg. Okay, so now we'll apply that. So we have the lambda value now. So now what we need to do is we need to prove that our object moves in simple harmonic motion. Okay, so now what we realize that we take it a distance 12 meters above the center. Therefore, the amplitude is 12. So I'm going to consider a general position, the general position of this spring during its simple harmonic motion. Okay, so I will consider some point like this. So this is the center. Okay, so this is the natural length position. Well is the natural length. So I'm considering a general point. Okay, a general point which is measured x distance away from the center because we measure the distance travel from the center, right? For SHM. Okay, so I will mark a general point. So let's mark all the forces here and first let's apply F equals MA, right? So first we'll apply F equal MA and let's get the omega value. Let's get the omega value and then afterwards we will find the periodic time. Okay. So what are the forces that are acting here? So once again, you have the tension acting upwards and you have the weight acting mg. Okay. So now the tension is completely different because you are at a different place. Okay. So let's apply the equation now. F equals ma. Moving downwards. Okay, so what are the forces I have? Mg minus tension, right? Mg minus tension equals m acceleration x double dot, because when you measure x away from the center, x double dot is also measured away from the center. So mg minus t. What about the tension? Tension is at this point, the tension is lambda x over L. So lambda value we just found, it's half mg. What about the extension? Now, does this x here mean this x value? No, the x here means how much here the string has how much your string is stretched beyond the natural length. Okay, so how far has it stretched beyond this natural length? This 2L is the natural length. So it's 4L plus x. The natural extension is 4L plus x. Over L is the natural length, which is 2L. So apply that value here. So lambda times 4L plus x divided by 2L equals mx double dot mass and x double dot. Mass is m, right? Yeah, particle of mass m. So let's simplify. Mg minus lambda is half mg, right? Lambda is half mg into 4L plus x over 2L equals mx double dot. M we can cancel out, yeah. M is common to everyone. So I get G minus, I get here G over 4L times 4L plus x equals x double dot. So when I open G minus G over 4L into 4L, the 4L cancels out. This is minus Gx equals x double dot. Sorry, Gx over 4L, x double dot, right? Yeah, this is G over 4L into x here. So G, positive G, negative G cancels off. So I get an equation. Can you see? Equation x double dot equals minus G over 4L x double dot. Sorry, not x double dot, it's x. Yeah, so then this is x double dot equal minus omega square x. Okay, x double dot equal minus omega square x. Okay, so we are now I need to show the periodic time. So capital T equals 4 pi root L over G. How do I get the periodic time? Give the conclusion here. Hence, object moves with SHM, because whenever you get an equation x double dot equal minus omega square x type, it's moving with SHM. Hence, object moves with SHM. And then we can find the periodic time. T equals 2 pi over omega. So what's the omega value? Root G over 4L. So 2 pi into root, we can put 4L over G like this. And then, yeah, the 4, we can bring it out of the root. The 4 comes out, multiplies it 2. So I get 4 pi root L over G, which is the show that. Can you see? This is the show that. So moving on to part B, find in terms of M, L, and G the kinetic energy of P as it passes through E. So E is the center. So when you pass through the center of your simple harmonic motion, it means you are traveling at the maximum velocity. So we will use for part B. So for part B, I will use the equation V square equal omega square, A square minus X square. So I want to find the velocity at point E. So it's the maximum velocity because it's the center. Omega square is already found here. So here this is G over 4L. This is minus omega square X. G over 4L is your omega square. Right? In the X double dot equation equal minus omega square X. So omega square is G over 2L. Into amplitude square. So amplitude, I told you at the very beginning, we raised this distance 2L above E. Therefore, 2L is the amplitude. So amplitude square is going to be 4L square, the square of 2L. minus x square. So when you're passing through E, yeah, x is the distance measured from the center in these equations. So x is 0. Okay. So I get here v square equals g 2gl, right? V square equals 2gl. Yeah, the omega square value is g over 4l. Yeah, so this should be g over 4l. So when the 4 and 4 cancels, I get simply gl. So v square is v is root gl. So getting the kinetic energy. So getting the kinetic energy at E, half mv square. So what's the mass? Mass is m. Velocity is root gl. So root gl square. So half mgl. Okay, so half mgl is the kinetic energy at E. So moving on to part C, they say find in terms of capital T. Okay, so they want you to get the answer in terms of capital T. So who is capital T? Capital T is the answer that we got the periodic time, right? Periodic time is capital T. Find in terms of capital T the exact time from the instant when P is released to the instant P has moved a distance 3L. So, we are releasing it at the stop point, right? Yeah, they are raising it a distance too well above the center. That's why I told 2L is the amplitude, and then they are releasing it. So they want you to find in terms of the exact time when P is released to the instant when P has moved distance 3L. So 3L means it's passing the center, and you're passing the center and going another a further distance of L, right? You travel a further distance of L. So there are two ways of getting the periodic time. One is x equal. The direct method is x equal a cos omega t. And when you pass, because you start from the amplitude, when your motion starts from amplitude, we use x equal a cos omega t. So we can use that. And but if it passes the center, then we have to use x as a negative L. The distance is always measured from the center, or else what we can do is I prefer to go in the way where from the center to the amplitude, we have a quarter of the periodic time, right? From the center to the amplitude, it's a quarter of your period, it's a quarter of the periodic time. And then from center, we are traveling a distance of L. So because I'm considering the center as the starting point for the distance, the L distance journey. And I'll use x equal a sine omega t and find the time taken for that. And I'll add it to t over 4. That's another way of doing. Okay, so the direct method is by using x equal a cos omega t and using x as minus L. Okay, because x is the distance measured from the center. So part C. Okay, so if you go with the method that I said first, the particle first travels a quarter of the periodic time by traveling from the place where you release it to the center until point it's a quarter of the periodic time. And then the remaining time is T1, the time taken to travel the distance L from the center. So to find that, I'm using x equals a sine omega t. So a is the amplitude, x is L, right? Yeah, traveling a distance L from the center. A is amplitude is 2L, right? And sine omega t. T1. So in this case, L over 2L, I get half equals sine omega t1. So sine inverse half, how much is it? 5 over 6 equals omega. Omega value was omega square is g over 4L, which means omega is root g over 4L into T1. So time taken is pi over 6 into root 4L over g, because it comes as a reciprocal. So this is the, this is your T1. And then we need to, however, bear in mind, we need to give our answer in terms of capital T. Okay, so we have to give our answer in terms of capital T. Okay. So I get here capital T over 4 is anyway there here, plus T1 was how much? Pi over 6 times root 4L over g. I can take the 4 out. Yeah, so when you take the 4 out of the root, it comes as 2. 2 over 6. 2 over 6 is 1 over 3 pi times root L over G. Are you with me? So, okay, now I need to input T into this answer because they want the answer in terms of capital T. So, what did we know here? 4 pi times root L over G is capital T. Or you could say, I think we already have pi times root L over G, isn't it? So pi times root L over G equals, if you take 4 to the side, it's T over 4. Can you see? So I can replace pi root L over G here. This pi root L over G is T over 4. So T over 4 plus 1 over 3 times T over 4. So T over 4 plus T over 12. Then we'll multiply this with 3 to get the common denominator. So I get here 3T over 12 plus T over 12, 4T over 12, which is T over 3. So this is actually the longer way. So the shorter method would be there you use x equals a cos omega t, and because when you x is the distance measured from the center and x equal a cos omega t is only used if the SHM starts from the amplitude. And then if you're starting from the amplitude and if you pass the center, if you go past the center, then the x distances are going to be marked as negative. So in this case, we pass this, x is the distance measured from the center, and so x is negative well because we have passed a full amplitude from here to here and we are going to the other side. So x is negative well, amplitude is 2L cos omega t1. So I get here minus half equals cos omega t1. How much is cos inverse minus half? Cos inverse minus half, quickly. Two pi over 3 is omega is root g over 4L t1. So I get here 2 pi over 3 into 4L over G equals T1. And when I take the 2 out, so I get here 4 pi over 3 times root L over G. Then I just now told you pi, yeah, 4 pi, yeah, we directly have 4 pi root L over G, right? So if I separate 1 over 3 times 4 pi root L over G, 4 pi root L over G is capital T. So you get 1 over 3 into T. T over 3. So it's a lesser amount of working. Can you see? So this is the answer. They say a particle P of mass m is attached to one end of a light elastic string of natural length A and modulus of elasticity 2 mg. The other end of the string is attached to a fixed point O on a rough plane which is inclined to the horizontal at an angle alpha. The string lies along a line of greater slope of the plane. The particle P is held at rest on the plane at the point A. So at point A you keep it. Where OA equals simple A as shown in figure 5. Particle P is released from A and slides down the plane, coming to rest at the point B. The coefficient of friction between P and the plane is mu, where mu is less than tan alpha. Air resistance is modeled as being negligible. Show that AB equals A sine alpha minus mu cos alpha. Okay, so it's 5 marks. Okay, so okay, let's read this again and try to understand. Okay, so we need to mark the point B now. Okay, so they say here the particle P is released from A and slides down the plane, coming to rest at the point B. So I will arbitrarily mark somewhere here point B. So from P to B, the particle slides down and it comes to rest at point B. Okay. So they say here air resistance is modeled as being negligible. Show that AB is alpha sine alpha minus mu cos alpha. Okay. So what's the theory we use here? Basically, it's an elastic string. So you start from the point P at rest, and then you come to point B, and at point P also it comes to rest. So what's the theory we use here? The theory we use here is the work energy principle. So work done against friction is equal to change in energy. So let's talk about the energy differences we have here. So what are the energies we have? Starting at point P, while traveling from P to B, you realize you are moving down, you're sliding down. So you definitely have a potential energy loss, right? You have a PE loss, right? So starting at this point here, so at the point P, you have from point traveling P to B, you have a PE loss. So to get that, we use mgh. So mass is mg, h is, so to get h is the vertical height. So the vertical height is AB. So you know this alpha comes here, right? The same alpha over here is over here. So it's AB, not cos alpha, AB sine alpha, right? H is AB sine alpha, right? So, or you could say the distance AB as x. Anyway, we are supposed to find the length of, show that AB is equal to this. Okay, so you could say if you want AB is x. If you use distance AB as x, then it's x sine alpha. Okay. Okay, mg into x sine alpha, this is the potential energy loss. And then when you travel from P to B, now at P, you are at the natural length. So when you come to B, you realize the string is fully stretched, right? It's fully stretched. So you definitely have the elastic potential energy. So you have what? At P, there's no EPE because it's at natural length. But when it comes to B, there is an elastic potential energy gain, right? So EPE gain, the equation is lambda x square over 12. Lambda value is given as 2mg. X value, the extension is x square from P to B. And 2 times natural length is A. So when we simplify, I get mgx square over A. Okay, I get mgx square over A. Okay, and then okay, so then we will find the work done against friction. So work done against friction is going to be force into distance. So here the force is the friction force, which is the maximum friction because we are moving. So mu r into distance is the AB, which is x. So mu is part of your answer. If you see the show that mu is part of your answer, so do not try to, mu should be there. Okay, so we do not need to substitute anything into mu. R is the normal reaction. So you do realize the mass is mg, and normally when you take the components, this side you have mg cos alpha, right, which is equal to the normal reaction. So normal reaction is generally it's equal to the mg cos alpha. We do not have any other force perpendicular to the plane. So normal reaction is equal to mg cos alpha into x. Is this clear? Okay, so now we have to apply this into the work energy principle. So work done against friction is equal to what? How do we apply now? You know, you do realize we do not have kinetic energy at either place, right? Starting, we start at rest, and ending, we end at rest. So there's no kinetic, there is movement, but starting and ending are both at rest. So we do not have a kinetic energy difference. So how do we apply these two rules? So you do realize at the starting point, you start at a higher point, you end at a lower point. So the potential energy loss is what we consider as the initial minus final. So potential energy loss, and then from the initial you subtract the final energy. Final energy is the energy at B. At this point, you have reached the lowest point in your motion, and at this point the string is fully stretched. Thereby you have the elastic potential energy. So you could put there the EPE gain. Okay, so work done against friction is mu mg cos alpha times x. Potential energy loss is mg x sine alpha. Elastic potential energy is mg x square over A. Is that okay? So simplifying, we can cancel out mg from everyone, right? Mg cancels out from everyone. And then, okay. Yeah, we can remove one x term as well, right? X is also common to everyone. So x square. So one x removes and x is remaining. So I'll take the x over A to this side, and I'll remove the mu cos alpha to the other side. Minus x over A comes as positive x over A. Here I am remaining with sine alpha. Mu cos alpha comes as negative mu cos alpha. So x equals A times Sine alpha minus mu cos alpha. So x is where x is the AB. We know x is what we found as AB. So this is your show that. This is the show that for part A, 5 marks. Part B, they say given that tan alpha equals 3 over 4 and mu is equal to half. Find in terms of A and G the maximum speed of P as it moves from A to B. Okay. So they are asking you to find the maximum speed of this object as it moves from A to B. So you realize at this point it's starting at rest and then it's moving down and it attains a certain speed and then it again decelerates. It comes to a speed of 0. So what's the maximum speed you obtain? Where do you obtain? So so how do we find it? Okay, so let me erase a few of these things here. Okay, so what we do here is, let's say, okay, so we will take a random point where we think, okay, so arbitrary point. So let's say the distance, this is the point C. This is the point C in between A, B. So at point C, this is the place where you achieve the maximum velocity. Okay, so you are increasing in speed, increasing in velocity until point C, and then after C, you decrease in velocity. Okay, so let's say the distance C to A to C is Y. Okay, so use some letter. So A to C distance is Y. So how do we get the, so this at C we have the maximum speed. Let me mark at C we have V max. Okay, so what we do here is again, we will consider the work energy principle. Okay, so again, I will consider the work energy principle from where to where? I will consider the work energy principle from, not from A to B, now from A to C. Okay, so again, what are the energies we need to consider? So what energies do we have? Starting at, again, we have work done against friction. Work done against friction from A to C. What is the work done against friction? Friction force is mu r, force into distance. Distance, what's the distance? How much of a distance are you moving against friction when you travel from A to C? So I'm assuming C is the place where I reach the maximum velocity. So I have marked the distance as Y. So mu into normal reaction is mg cos alpha into Y. Do you agree with me? Shall we actually input the values? They have told us mu is half into mg. Can I know the cos alpha value? If tan alpha is 3 over 4, 3 over 4 opposite over adjacent, the hypotenuse will be 5, which gives me cos alpha is adjacent over hypotenuse, 4 over 5. Do you agree? 4 over 5 into Y. Okay, so can you simplify? What do I get for the work done against friction? 2 mg over 5 times Y. Okay, and then the next one, what are the energies do we have here? When you consider so we need to consider the change in energy, right? From P to C, what are the changes in energies that you have? So starting at point P, when you come down to point C, you know you are definitely experiencing a potential energy gain or loss. When you come down from P to C, it's a potential energy loss. So can I know the potential energy loss value? Normally potential energy is mgh. How much is the height, the vertical height? Yeah, so you realize it's you have to resolve the y. So this is the high distance, the angle alpha is here. So it's y sine alpha, isn't it? mgh is y sine alpha. Okay, so it's y sine alpha. Can I know the sine alpha ratio from the triangle? Sine alpha is opposite over hypotenuse, 3 over 5. So mg y sine alpha is 3 over 5. So I get 3 mgy, 3 over 5 mgy. Is that correct? Okay, and then the next energy we need to consider when you move from P to C. That from P to C, what else do we have? We have the gain in what? Yeah, we have gain in kinetic energy because at point C we have the maximum speed. So obviously you have a speed here, right? So you have a speed, which means definitely you have kinetic energy. So you have a gain in kinetic energy at C. At C you have a gain in kinetic energy, which is what? Half mv square. So I don't think there's anything to input here, right? Okay, is that all? Is that all the energies I have to consider? There's elastic potential energy also, right? Because at P is at natural length, you move to C, your string is stretched a distance Y. So you have gain in elastic potential energy. which is lambda x square over 2L. So lambda is 2mg x square, the y value, the y square over 2 times natural length is a. So when you simplify, 2 cancels out, we get mgy square over a. Are you with me? Okay, time to use all these values in the work energy principle rule. So work energy principle equals work done against friction. Work done against friction equals change in energy, right? Initial energy minus final energy. This is the equation. Okay, so what are the changes in energy that we have? Okay, so first place is where we start. So you can see definitely initial energy is higher than the final. So initial place where we start, you can see the only energy that we consider is it's above the lowest point. It's above, it's going below. Therefore, we use the potential energy loss is what we consider as the beginning. So potential energy loss. Then at C, what do we have? So minus initial energy minus the final energy. At the final stage, you have a gain in kinetic energy and a gain in elastic potential energy. So you have to, from the initial energy, you have to subtract the final energies. So when you subtract the gain in kinetic energy, half mv square, also subtract the mgy square over a, right? Okay, so work done against friction was, the simplified answer, what was it? 2 mgy over 5. Do you agree? So let's input the value 2 mgy over 5. Potential energy loss was? Potential energy loss was 3 mgy over 5. Minus half mv square. We do not have anything to input. This is minus mgy square over a. Actually, I should have written this as, sorry, I should have written these values here, right? This is Ke gain. And this is elastic potential energy gain. And then I'll put the values here. So M cancels. Is M the only one that cancels? Yes. Okay, so you can see we have an equation with many unknowns. Okay, G is a constant 9.8. Y is the distance that you have traveled. So actually you can see here I have a function. What are the variables here? Velocity is a variable, right? It's not a constant. Y is a variable. So you can see we have an equation that is varying with respect to Y and V, isn't it? So if I bring the minus half V square here as a plus half V square and take the 2mgy to the other side, so I have 3 over 5 gy subtracting with 2 over 5 gy minus gy square over a. Are you with me? So actually, if I make v square the subject, I get here 3 times 2, 6 over 5 gy, multiplying everyone with 2, 4 over 5 gy minus g over a times, 2g over a times y square. Okay, so you multiply everyone with 2. Now, this 2, okay. Yeah, we can simplify 6 over 5 and minus 4 over 5 as 2 over 5 gy. Yeah, these two terms we can simplify, they're like terms. Minus 2g over a times y square. So do you see I have a function of function for the velocity in terms of y? Y is the displacement, the distance you travel starting from the point A. Right? So what I want here is I want the value of y such that what happens? I want the value of y such that v is a maximum because I want to find the maximum velocity. So to get the value of y that gives the maximum v, you do realize it's a quadratic function in y, right? There's a minus y square function. There's a y, so it's a negative y square function, means the quadratic maximum graph. So I want to find the maximum point. So let's differentiate this equation and get the maximum point. Set it to 0, get the maximum point. Y value, substitute it back to this equation and get the y value who gives you the maximum v square. Okay. So let's differentiate. When you differentiate, what do you get? 2 over 5g. Okay, now don't go to differentiate v squares to v. We don't need to do that, right? All our concern is that this is a quadratic and I want to get the maximum value of this quadratic graph. Okay, that's what we need to do. And then find the y who gives the maximum v square. So I'll just differentiate 2g, y differentiation is 1 minus 4ga y square, the 2 comes in front. So set it to 0. So you get 2g over 5 equals 4g over a into y. So the g cancels Yeah, 2 and 4. Also, I'll just make y the subject. So I get y equals 2a over 5 times 4, right? Which gives me y equals a over 10. So this is the y value who is capable of giving, who is giving the maximum value for this quadratic graph. So input that y value here into the v square equation, and I get v square equals 2 over 5gy. Instead of y, I use a over 10 minus 2g over a into y square is when you square it, right? Which is a square over 100. So when you simplify, I get here v square equals 2g, sorry, 1 over 25, right? 1 over 25 GA. When you simplify 2 over 5 into 1 over 10. When you simplify 2 into 100 to 2 into 1 over 100, it's 1 over 50 G. The A cancels out. So 1A cancels 1 over 50 GA. Simplifying my 1 over 25 GA minus 1 over 50 GA. What do we get? We get 1 over 50 GA. So V equals to square root of 1 over 50 GA meters per second. Okay, so square root of 1 over 50 GA. So this is the value of, this is the maximum speed achieved during the motion. Okay. So moving on to part C, they say describe the motion of P after it reaches B, justifying your answer. Okay. So you have to describe what happens to the particle when it comes to B. So you realize that you release at B, then it comes to the maximum velocity at point C, and then it again slows down and comes to B. So after reaching B, is it going to stay at rest at B, or because it's fully stretched now at B? So your task is will it go back up again? Is it going to go up again, or will it actually stay there at rest? So that's the task. This is the angle B. So this is the point B, let's say. So now at point B, your particle is here. So you have they're asking you to decide whether this particle, it's fully stretched now. You're supposed to decide whether it will move up again. So what are the forces you have at this point? You know you have tension definitely acting upwards. What else? The normal reaction, the weight. So we will take the weight components, right? We need to work with the weight components, which are mg cos alpha, and the special one that we need here is mg sin alpha. So these directions are fixed. The tension, the mg sin alpha directions are fixed. So the friction force depending, so actually at this point, so now we need to, so if you are trying to move up, okay, if you're trying to move up, then you know the friction is opposing, so friction will try to back downwards. So now what we need to see is we need to see whether this tension force is sufficient enough to overcome the mg sin alpha and the friction. So friction in the sense, the maximum friction that we can give is the mu r. So you have to see whether it's capable, whether it's capable of generating more than that. Okay, so let's try to get the value here. Okay, so let's get the tension value. What is tension? Tension is lambda x over lambda x over, well, first of all, we'll need to calculate the x value, the AB length. The x value is the AB length. So input the value sin alpha mu cos alpha into AB. AB equals A times sin alpha is 3 over 5 using the equation in part A, minus mu is half times cos alpha 4 over 5. Can I have how much is the AB length? 3 over 5 minus 2 over 5, right? It's just 1A over 5. So this is the AB length. Okay, so then when we, so that AB length is directly the extension of the string, isn't it? Because the natural length is at P, the AB length is the extension. So AB length, tension equals lambda x over L. Lambda is given in the question as 2 mg, right? Modulus of elasticity, lambda is 2 mg into x is the extension A over 5 over natural length is A. So A will cancel out, and then you get tension as 2 over 5 mg. Okay, so you get tension as 2 over 5 mg. Okay, and then what about the weight component downwards? mg sine weight component along the plane. Mg sine alpha, which is m into g sine alpha, is 3/5. So it's 3/5 mg. What about the maximum friction? F max is mu r. Mu is given as half, right? Normal reaction mg cos alpha. So get the value. Half into mg cos alpha is 4/5. So F max is 2/5 mg. Now you do realize that the maximum friction you can get is 2/5 mg. However, you are capable of giving a friction value more or less than this if it's not required. Now, for instance, here, so what do we need to calculate? Let's calculate the forces here. So tension. Okay, so how do we say this? Okay, so I need to check whether this friction, whether I have the maximum friction here, or are we applying a friction less than the maximum friction? Okay, so how do we get that? Let's get the T minus mg sine alpha value. Okay, get the difference between tension and the mg sine alpha first. What's the difference? That gives you the net force acting down along the plane, right? So how much is tension? 2/5 mg minus mg sine alpha. Weight component was 3/5 mg, right? Or instead of doing that, let's take it the other way. Net force down along the plane is 3/5 mg minus 2/5 mg. How much is it? 1/5 mg. So you have this much of force acting down. Okay, so then what about the friction? You have how much of a friction? 2/5 mg. So what do you think? This friction, is this sufficient? Is it sufficient to prevent the particle from moving up? So actually you can see, yeah. Yeah, so what can you see here? Okay, so the thing here you need to realize is you have a net force downwards. The mg sine alpha is higher than the tension, right? So so we were thinking that this came down here and it stopped and it would try to go up, but actually what you see is mg sine alpha is higher. 3/5 mg is higher than 2/5 mg. So which means, and if it's at rest here, so if it's at rest here, what does it mean? It means if your friction to this direction, to balance it out, now they say it's at rest at this point, right? So first thing you realize is, since tension is lower and mg sine alpha is higher, okay, so it has no intention of returning up, first of all. Okay, so then the thing you need to realize is this is not going to, definitely it's not going to come up, and if it's remaining at rest here, the friction should be what? Acting upwards. And how much of a friction are we having upwards? So you have the net force. The net force is 1/5 mg is what's acting downwards. So the so friction must be capable of giving that exact amount to keep this in equilibrium. Okay. So then the friction force acting here is how much? We don't have the maximum friction. The friction force in this question is 1/5 mg, and in which direction? 1/5 mg upwards along the plane. Okay, and then what else are they asking you? Describe the motion of B. So what about the motion of the particle? The particle remains at B. Can you see? The particle is remaining at B. Please, it's not going to move. Is this clear? Okay, so this is the end of this mechanics paper.